So the first thing is you need to create a project. Go to file and click on this new project and give the project name and add some description to the project. Project name is Atmega 328P board, and I can write some basic thing in the description, basic circuit of Atmega 328, and just click on this save. After that, this we have created a sheet, and you can if you notice, this is our sheet, and at the center, at the bottom, if you see, we have the title, the company name, date, etc. of the project. So I can just write this. I can even change this. All of this can be changed easily. And the second thing important is the wiring tools. This is the palette for the wiring tools. It has a lot of option. One more palette is the drawing palette. Uh, it has also the same options, but we will use these wiring tools a lot. Okay. And if you notice this, we can increase the usable area by clicking on this. And at this left side, we have this project. Second is the design manager. Third is the common libraries which we can pick some component or the symbols for the schematic. Fourth option is the library where you can search for component online. So this is the library. You can search for customized symbols also. That's how we will work on this. Now we can increase this usable area by the clicking on this and start with the assigning placing all of these symbols. First I will select this Atmega 328P microcontroller. So I can select any of the microcontrollers. It should be like TQFP package. I will use all of the assembly components. So this is a microcontroller symbol. VCC to the common VCC and connect the 5 volt. I need a like a capacitor, zero point 0.1 microfarad. I will use the 0805 package. You can also go to this user contributed symbols. They also have the customized footprint. You can also create your symbols and footprint. So I can select this any one of the capacitor 005. I will select the schematic and just click on this. You can zoom in and zoom out with the help of the scroll from the mouse. And if you need to place any component, like left click from the mouse, and if you don't want to release any component, just click escape. So I need this two capacitor and the one ground. If you want to copy this component, just left click from the mouse and just Control C and Control V. This is the wiring tool which I am using. Start from the point. If you want to copy paste, you just need to left click from the mouse and just do Control C, Control V. Same for the moving the component from one place to another. You can just left click from the mouse and just drag it. I need 1 kilo ohm resistor, pull up resistor. That also I am using 005 package. So I'm moving it like just moving the mouse and just left click wherever you have to place it and then click escape. I can move this whole object and I can put a net label so that it looks neat. This is the net label. So for example, if I add a reference here, so same things will be written wherever we need to connect that. I can place it somewhere here. So I need to connect it to this reset pin. I can move this a reference, make this schematic looks neat and clean. I can copy paste this 5 volt, I can place this and I can search for a reset button from this common library. Yeah, so I can use this SMD reset button. And now you can also see this footprint for that selected reset from the right panel. I can use this wiring tool to wire it. So to wire it, just left click from the mouse and left click to the starting point and the ending point and just click escape. I need a 16 megahertz crystal, so I will search for the SMD one 2 pin. So we can just click on this place and place this component near this crystal XT1 and XT2. I also need a 18 picofarad capacitor 0805 package. Just search for whatever you want in this and select the proper symbols according to the part number. Click on this place. I need to just left click and again I will left click, click escape. Now I will copy paste this ground and use the wiring tool. Make sure where I am connecting this is proper. Then the crystal part is complete. Now I will just put the ground to all of this ground pin. Just make it common and copy paste this ground here and we can just connect it. Then we'll be left with the ICSP headers. So I will select a connector header ICSP 2x3. I need the same which means have on the Arduino like this, but it is SMD1. After that, you can just put the common 5 or 10 first, then connect it to the plus V and ground of the ICSP header. Also, we need a RSG at the ICSP. So I will use the net label and I can write RSG. Same I can copy paste there. So this T13 is the serial clock. I can just copy paste it, left click, Control C, Control V. You can even change this name by left clicking, double left click, and you can write the names as ISO. And copy paste the same net to the particular ICSP header pins. And I will just connect them. After that, we will use a no connection flag like this, no connect flag. So the unused pin, I will just put it with this cross or no connection flag so that it does not give any errors in the rule check, design rule check. Place it properly on the pins, otherwise it will show this option. You need to just delete it and make a new one. So we are almost done with the schematic. After that, you need to save the schematic and click on this design and update PCB to schematic. You can change this board layout by double click, left click. So you will see this footprint and you can just left click from the mouse and move the component. You will see this white line. So according to that, you arrange the component. I will place this crystal close to these pins, and we need to two coupling capacitors. Place it like they can easily routed. I can place this A reference close to these pins, and if you see we have this decoupling capacitor. So I will place it somewhere near the 5 volt and the ground. Place this reset near the reset pin. so that they can easily route it, and you can change this R1 and other so they look neat and clean. So it is easier for you to solder them. So I will place this crystal arrangement in this fashion. I can place this decoupling capacitor close to the microcontroller pins. C2 is the A reference, and this is the ICSP. I can move it somewhere. Go on saving the work by controllers, and after that um, you can place the mounting holes from these PCB tools. So this option hole, so just left click and place it wherever you want. So we'll place it at the corners. Make sure they are aligned properly. I need 4 mounting holes at the 4 corners of the PCB. And then even check the uh, whether they are in current orientation by this dimension. Just measure them with the top one to the bottom one. Select the starting point and the ending point, like left click, and then you can even measure the dimension of the board by this dimension tool. So the 34 cross 22 mm board. Now I will use the copper area, a copper core. But before that, let's do the routing. I will first connect this crystal circuitry in this way. Click on this wire tool and select the starting point and the ending point from the left click from the mouse. We will connect this ground later on. We will connect this 5 volt RST. Connect this ground 5 volt with this 5 volt. You can change the track thickness also. If you need to change the direction of this routing, you need to left click, and from that point it will change the direction. Make sure to have a proper spacing between the tracks and the pads. Now for this serial clock, I can, in this case, I am just left clicking from the mouse to change the direction. For this MOSI pin, it will not be connected as there are a lot of tracks and pads in between. So I will use this wire, place it on the MOSI and click on this wire and change the layer from the right side, and you will see this blue color on the track which is at the bottom layer. Red is the top one. The tracks on the top one are in red color and the pads are also in red color. So that is the top layer. This is I'm making a long track as there is no path for it. After you have completed on this, click on this um, and make the copper core by selecting all of the corners of the board. Go on left clicking and at the end double left click to make it as the copper core. So on the top layer we have this copper core. So this is how our PCB look like. On the bottom layer we cannot make it as we have only one track. And this is how you can make design your PCB. You can also have a 3D view of this PCB. Once you are done with that, you can also do the design rule check from the design and click on this check DRC. At the left side, you will see DRC error. There are 0 DRC errors. So this is how you can work on this PCB.